from Teleco, from the school next to here. But I live in Chicago. I've been living in Chicago for the last almost 10 years, almost as old as the Android system. And I'm the developer that is going to be talking about Dart. Perfect talk after Jorge's talk, right? So why are we talking about Dart? And in this case, why are we talking about Dart for mobile developers? I'm sure that everyone here has heard about Flutter. It's this new framework from Google that it's promising like cross-platform development, at least in terms of the UI, right? It brings like a very revolutionary way of approaching UI development, and they're targeting iOS and Android, that's for sure, but now they're approaching other platforms as well, such as like macOS, web, desktop, like pretty much anywhere where you can put pixels on a screen, you're gonna be able, or you can use Flutter these days, right? And in our case, Dart is the language that powers Flutter. And there has been a lot of kind of like, hey, why is Flutter using Dart? Like Kotlin is much better, things like that. Well, we're gonna learn the reasons why Dart is actually a pretty good language. I've been using it for almost 2 years already. Before that, I was using Kotlin, I was using Java, I've used TypeScript, Ruby, like plenty of languages, and I'm actually quite impressed with that because it brings to the table a lot of qualities that other languages don't use or they don't provide. And in this case, it makes it the perfect kind of like complement to Flutter. So a little bit of history about Dart. Dart, like the premise is that it's a client optimized language, right? We can see it in Flutter, but like Dart was born as a replacement for JavaScript. Google needed to scale their projects, and they were like, oh, we need a new language because JavaScript is not sufficient for us on the web, right? But now it's turning into these replacements for JavaScript to, hey, we can run Dart pretty much anywhere, but we're deciding to optimize it for like client UI projects. It inherits a lot of the best qualities from JavaScript, from Java, from C#, so it's very easy to learn. I would say that everyone that is here already, if you know any other language, you know Dart already, congratulations, put it on your resume. Because it kind of like, it receives all those good qualities from languages that are very familiar to every developer, right? The first version, well, not the first version, at least the language was introduced in October of 2011. Again, like the promise for Google, it was developed internally at Google. They were like, hey, we need to scale our kind of like front-end solutions, and JavaScript is not enough for us. So 2 years later, November 2013, they released version 1.0 of Dart. And like probably as you know already, Google was also working on Angular, right? So they ported or they migrated Angular to Dart as well. So now they have AngularJS and Angular Dart. And they had very big ambition plans for Dart, actually. Like for a while, like Chromium, like Google Chrome, had support for the Dart virtual machine and for the JavaScript virtual machine with V8, right? And they were thinking that Dart would become that replacement for JavaScript. Well, it didn't turn out that way, right? Like we have now other solutions that pretty much what they do is to compile or transpile other languages to JavaScript, like TypeScript, right? Or like Dart in this case. So they stopped those ambitions. And for a while they were like, is Dart gonna die or something like that? Well, that's when like actually the marriage with Flutter was perfect, because last year Dart announced version 2.0 of the language is more mature, the type system is way better, the integration with UI projects is actually really, really nice. And as of today, we are in version 2.7, right? And probably if you've been following like the news, the community, Twitter, all the stuff, everyone that starts trying Flutter or Dart, they kind of like it immediately, right? So there's a lot of growth in the community. If you follow me on Twitter, I'm that it's always talking about Flutter and Dart and all that stuff. But not only because the language is great, like that's the first step, but there's also like a really nice big community growing around these technologies, right? So when I said that everyone knows that already, it's because, well, if you see this piece of code, this snippet, you know what it's doing. You have your main method, it's the entry point for every Dart application, right? Regardless if it's Flutter or Angular Dart or any other like backend solution. And in this case, we're just doing a simple message. We're just kind of like logging on the console like, hey, hello, DroidCon, and we can use emojis. The support for emojis is awesome. Everyone loves it, so there's no point. We can do things a little bit more complex. In this case, we have our main method. It takes a list of arguments in the format of a string, right? So now we have lists in there as well. They support genetics. That's why we can pass like the string in there and all the stuff. We can check some nullability. We have a string interpolation, all the kind of like simple things that you might expect, right? But even if you wanted to do something a little bit more complex, like making a network call and parsing some JSON code, it's as simple as using the feature API. And even though probably you coming from the Android world, you're used to like coroutines or RxJava and all the stuff, you might be thinking like, hey, feature APIs, what does that mean? Well, actually, it feels very natural, right? It feels very familiar. A feature is like something that is going to happen eventually. It's kind of like a promise, and you can get either a successful result or an error, right? So in this case, we can see in here that our API describes that we're going to return a feature, and there's these two nice words that even if you've never used them before, you kind of like know what they mean. You have an async method that you know that it's going to kind of like take some time to do something, and that await that it's kind of like the keyword that you use to just wait. I'm going to receive the result eventually. So what makes Dart special, right? We've seen a few snippets of code. Everyone here in the audience already knows Dart. So we're going to talk during this talk about three main pillars that make Dart special. The first one is that it's optimized for UI, right? So if you want to develop for like Flutter, Angular Dart, or anything like that, we're going to see what are the improvements in the Dart language that makes it like really nice to use in UI environments. We're going to talk about its productivity. Probably if you've seen Flutter, the first thing that everyone talks about is hot reload and how simple it is to just change your UI code, save the file, and you see the changes immediately happen without having to recompile your code and wait a few minutes and get that coffee. And finally, we're talking a lot about like Kotlin multi-platform and all the stuff. Well, actually, Dart is multi-platform. Like you can compile it to native. That's how you're able to push Dart code into iOS applications, right, and publish them in the App Store. Otherwise, Apple would be like, you're not coming. But also, you have the nice things of coming from its JavaScript pass, right? Like hot reload is powered by just-in-time compilation, that it's kind of like coming from the JavaScript world. So we're going to focus on those three areas, right? And let's start with optimize for UI. What does that mean? Well, there's a few things. First of all, Dart is an isolate-based concurrency language. So this is a little bit different than threads, right? Like with threads, you can share memory, but also like the way you access that memory, it's kind of, you have to lock it and then unlock it, and it's tricky, right? So in this case, isolates, it's kind of like what happens in JavaScript, right? And then you have an event loop execution model. So we're gonna look at that pretty much, but pretty much in your system, there's events happening, small tasks or more like chunks of code that are being processed. And there's always an event loop kind of like taking events from a certain queue, processing those, and then dispatching them, right? And kind of like this is a nicer solution, at least when it comes to UI, because thread management, it's kind of like complicated, and this is very easy to do in Dart. We're going to see the feature and the stream API. These are embedded in the language itself, so you don't need to rely on third-party packages like RxJava or coroutines and all the stuff. They're part of the system, right? Like, so that makes it very nice as well. And then we're going to see a few kind of like UI-driven operators, like the spread operator, the collection if, that when working with different kind of like integrations between your view models and the UI, they're really easy to manipulate, really easy to use. So isolate-based concurrency. Pretty much what happens is like each isolate, it's its own space in the machine, and an isolate doesn't know anything about any other isolates. And in most of your Dart projects, you're only going to have one isolate. If you want to spawn more isolates, feel free to do so, but most of the times it's not needed. These isolates, they don't have anything in common, and the way they communicate with each other is via messages. I can give you a message, you can serialize it, deserialize it, and all the stuff. You will make it to another isolates event loop and all the stuff, and then you can respond back to that message. But they don't share anything. Therefore, they have their own private memory, and it's kind of like a single thread with its event loop, right? So, for example, if you're working on a Flutter application, and like if I use the analogy of the Android, like you don't want to block the Android UI thread, right? Because then otherwise you see that all the frames stop and you're not doing anything. In this case, because there's an event loop, you can use these async await keywords, right? Like you don't have to kind of like switch threads from IO thread to the main thread and all that stuff. It's just like it's happening in the event loop. And as long as you don't have any computational operations that take longer than 16 milliseconds, that it's what ensures you to have like 60 frames per second, you're ready to go. But if you need to do something that it's very, very heavy, just spawn a different isolate, send a message, expect a message back, and that's it. In this case, a network operation is not considered heavy computational because pretty much in a network call, what you do is like send a message, just sit and wait, and then you will receive a JSON and decode it. So you don't even need to use different isolates for making network calls. So isolates, as you can see, they're a little bit different than what we are used to in the Android world, coming from Java, JVM, Kotlin, all the stuff. But like this is the kind of like the threading model, or at least kind of like the concurrency model that it's behind JavaScript and Node applications, right? So if everyone or like someone here has been doing like backend development, it's common to use that type of kind of like programming there. Because there's no shared memory, there's no logs. That's great news. I failed all the computing classes about concurrency when I was studying here. So for me, not having to use logs is like, yeah. But it's also like a very common pattern in other languages, right? Like if you're coming from Go or Rust, like these technologies, they have the same approach. They don't share they don't share memory. It works great. No one complains about it, right? And they're so much low level that you will barely use them. It's only like, again, like if you needed to do something that is like calculating the next number of pi, right? Like in that case, like good luck. Probably you need not a phone, a better computer. So if we compare them between like with threads, the main difference is like they don't share memory. In threads, you can communicate via messages, like you can do that as well, but also like they share memory, therefore, so you have to log, but at least the processor time in this case, it's both the same, it's equally shared between isolates and threads. So like this is kind of like a visual representation of how you would process your isolate, right? Like there's an event queue, like there's a timeline. You don't know when you're gonna receive events. You know that you're just gonna receive them. If you're not, you still have the event loop just idle, doing nothing, but it's kind of like just listening from time to time, right? And every time there's a new event, you put it in your processor, you dispatch that event, resolve it, and then on to the next one. So far, so good? Okay. So let's take a look to the future API, because now we've been talking that you can do operations, right? They're going to be captured by the event loop in this case. So in this case, we have this example that we're preparing tortilla. So as you can see, when I run the example, it prints first the making lunch. You might be thinking that it's blocking, but it's not blocking. It's just like delaying the operation. It's putting the operation in the queue, in the event queue, right? And eventually it will be processed. But it's not blocking anything in here. So in this case, if we were in a Flutter application and we had a loading spinner, you're still painting frames like every 16 milliseconds. As you can see, this is very, very powerful because you don't have to think about like, oh my God, I need to make a network call or like do something and switch to the IO thread, and I don't forget to switch back, and I have a leak here or there. Like this doesn't happen with this type of code, right? We also have streams. So there's an RxDart library, but streams and syncs are part of the async library in Dart. They're part of the language, right? So think of a stream just as an observable, or kind of like again, like a pipe where you can put events and you can start listening to those events. In this case, we're preparing dinner and we see that the first meal is gazpacho, it comes first, and then we process the other ones as we go, right? This is not the most perfect like Rx code, not even Rx, but like at least you can see that it gets the job done, right? So these are the kind of things that make UI development very easy, because you don't have to switch that context between like, hey, is this the IO thread? Is this the main thread and all the stuff? No, you just kind of like go with the flow. You start typing. You don't have to worry about things. Just worry about your business logic, which is a great improvement, right? Because it just simplifies your development and you can focus on what makes your problem the problem, not like think about the platform's problem. We're going to talk now about productive development, right? And the first thing that comes to mind is like code reload. It's like, oh my God, everyone has been blown away by like this idea of like I change a line of code, I save it, and I see my simulator or my real device reflecting those changes immediately. I can tell you, I've been working in a really big code base in Flutter for BMW with thousands of lines and like thousands of commits and like a few years of history. And hot reload still works perfectly. It's not the kind of thing that, oh my God, like the more code you add or anything like, no. We're incredibly happy. We're gonna see also some of the tooling that comes with Dart. And this one to me is funny because like last year I was when they were presenting like different tools for Android Studio to like analyze the performance of your application, and it was amazing. I was like, I've been using that in Dart for quite a while already, but sure, it's cool, right? Then we have another product called Dartpad. So if you Google Dartpad, it's kind of like a IDE in your browser. So if you wanna try snippets of code or whatever, you can just try in there, paste it, share it with people, and it works great, right? So sometimes like you don't have to have these GISTs or like these snippets when you're opening a bug. Just have a example that reflects your issue in Dartpad, put it in a GitHub issue or whatever, and everyone's happy. You don't have to recompile to test and fix the issue, right? Then there's another package manager called Pub. This is kind of like your Maven, or like if you're coming from the JavaScript world, this is kind of like NPM. So if you work on a library and you want to open source it and use it in your Dart projects, you want to publish it in here, and they've been making a lot of changes lately. So let's start with Hot Reload. Like if no one has seen Hot Reload, this is pretty much it. You have your IDE, and with Dart you can use VS Code or you can use IntelliJ products if you want. But pretty much in this case, it's a Flutter application where like you change some code, some text, save it, and we can see that the simulator reflects the changes immediately. And again, it looks like an Android application, but probably if you pay attention, it's an iOS simulator. So it's a Flutter application running the material design library, right? So how does Hot Reload work, right? And why Kotlin doesn't have Hot Reload, or like if Google has been promising like instant run for so long, why it doesn't work like this? Well, it's because Dart has a special compiler that it's called just-in-time compilation, JIT, right? That it's coming from its days from web development. And pretty much what it does is like very simple. It's like at runtime, it analyzes the delta between the last executable that you had and the new one. It just recompiles that part, right? So instead of recompiling the whole project, analyzing dependencies and all the stuff, when you're running in debug mode, that VM is smart enough to just recompile these changes very, very, very fast. We're talking about 100 of milliseconds, the longest. So it's very, very impressive, right? And again, like this is nothing new. This is just kind of like getting ideas from JavaScript that you might love it or hate it, but like it serves a purpose and it's a great language, right? We're talking also about like the different tooling that you could have with Flutter and with Dart in this case. And this is coming from the developer tools that you could get from Flutter or from Dart, but like this is kind of like your timeline view. So in this case, we have an application with multiple frames. If you want to run your application under 60 frames per second, right? Or like 60 frames per second, you have to ensure that all your processing has to be done within 16 milliseconds per frame, right? So we can see in here that those red bars, pretty much they mean like that frame lagged. So there was a junk in your animation or something, and it didn't make your application performant. It didn't make it look nice. But it's very easy now to understand that it's happening in there. And now you can go from there to the details of the frame and see what's kind of like blocking that code, or like maybe you have a computation that shouldn't be done in the main isolates. In that case, maybe you think about like spawning your own isolate and things like that, right? So views like this, for example, we can see that it goes from 0 to 16 milliseconds, and we see that it just stops before those 16 milliseconds. This means that we're good citizens, our kind of like our processing, our code is executing in the right amount of time, so we can move on into the next frame. But if this was longer than those 16 milliseconds, then we can jump into the details of those kind of like UI or GPU calls. We even have like a CPU profiler where we can analyze more in detail what's going on. Maybe it's not us, maybe it's the system, or we need to understand how we kind of like interacting with the system, right? Like I rarely use these kind of like tools. It's only when you're analyzing like performance and like things that are not working great. But this is the kind of thing that maybe you don't use it that much, only once every 2-3 months. But if you didn't have these tools, then you would be miserable, right? So this is really, really nice when you have it at handy, and they're very, very simple to use. You just kind of like click, drag and drop, zoom in, zoom out, and it's very easy to understand. It also comes, again, like this is a different way of seeing your stack call, right? So you can see what are the methods that are being called by the system, how long do they take, and all the stuff. Granted that this is also in debug mode, so because in debug you include the entire .vm, like it might take a little bit longer, but like I've already used this, but it's really, really nice to have, and it tells you how powerful Dart can be as well. This is another view of the logger, right? Like you can get like also calls from the system and get all the information, yada, yada. And then you have your debugger as well. So let's say that you're the kind of person that, or developer that only uses the terminal. You can just spin up your browser and you can get debugging in there for free. But also like if you're using an IDE like VS Code, IntelliJ, Android Studio, you can just put breakpoints or whatever you need and see the entire stack call and kind of like debug, step up, step down, whatever you need to do, right? So again, what I'm trying to say is like, you might be thinking that Dart is kind of like, oh, the new language that powers Flutter. It's actually not. It's been around for a long, long time, has very mature tools. It's used very heavily at Google internally and now by other companies as well as part of Flutter, but also like other companies invested in Angular Dart, backend code like Aqueduct, Angel. We're going to see that in a second. But like, so you can see it has all the tooling that you might expect. And then we had Dartpad, right? Like, I think we've seen a few snippets as part of the feature API example in the stream API, but this is pretty much really nice because if you need to do something and you don't want to actually install Dart in your computer because you just want to try it out, just use the web IDE, right? And not only you can run Dart code, but like you can also run full Flutter applications as long as you don't have kind of like external dependencies, right? Like it doesn't come with pubspec and like the package manager, but in this case you can launch the material library that it's part of the Flutter framework, or you can launch the Cupertino if you're like more into the iOS look and feel and get all the information that you need from the web IDE. So again, perfect if you're just trying to play with the language, test an animation, whatever you need. I actually have used this a lot in workshops. I've been kind of like going to high schools to teach teenagers how to use Flutter, and this was perfect because I don't want to spend time teaching the kids how to install Flutter. I just want them to see how powerful it is. And then pubspec is just like a website, pretty much. Go to pub.dev, and then you get the entire catalog of packages, and you can see in there, actually there, you're going to receive kind of like a score on your package depending on how well maintained it is, and that score is coming from like how many tests, the documentation, is it good or not? Like, are people using it, right? Because you might have the best documentation and the best test, but if no one cares about your package, then kind of like it runs out of fashion, right? And the way you define these dependencies is just with a YAML file. So in this case, this is again like just pure Dart. We're not talking about like how to integrate with Flutter and all that stuff, but you're gonna have a pubspec file where you're gonna define the metadata of your project. And at some point, you could just define in your dependencies like, hey, I need to rely on Flutter, secure storage, and all the stuff, and I want to pick this version. Actually, one of the cool things that I like about Dart as well is that it follows semantic versioning. So you pretty much can say like, hey, if I'm in version 1.0, between 1.0 and 2.0, since they're not supposed to be breaking changes in semantic versioning, just pick whatever is the latest, right? So that's pretty neat, but again, like very simple to use, is YAML, very readable. And then the third pillar that we were talking about, Dart in this case, is that it's fast on all platforms. And this is very, very important, right? Because we've seen it running on iOS and Android, but also like now we're targeting web, we're targeting desktop. So how do they achieve that? Well, first of all, it's because there's an ahead of time compilation that compiles your Dart code into native machine code, right? So this is very, very nice because we get the best from the JavaScript world, and now we get the best from native world, right? So if we're talking about Kotlin and all the stuff, this is the type of compilation that you have in JVM projects, but Hode Reload is achieved with just-in-time compilation, right? But again, if you needed to just target web, like Flutter web, what you do is to transpile your Dart code into the JavaScript code. So you also get that benefit as well. And because it's just a native compilation, you could run like backend projects as well, whatever you want, right? So actually, in this case, as part of like the iOS integration, and lately in 2.6 of Dart, you can actually compile and get a binary of your Dart code, right? And this is done with a utility called Dart to Native. So if you want to write CLI applications to execute even from your terminal, you can do that with Dart, and the receiver of that project doesn't need to have Dart installed on their computer. With Dart.js, you can target web. This is one of the latest Flutter projects targeting web. It's a Flutter gallery. All this is Flutter code, right? And this is done with another transpiler library called Dart2JS. So again, you can just get your Dart code and translate it to JavaScript. There's backend support as well in Dart. So if you need it, like this is very handy if you have a type of architecture that mixes backend for frontends and your clients. This means that you could be able to reuse a lot of the, especially around the models, like the JSON models. You can target that with Aqueduct, or like Angel is a different framework. They both work quite well. Actually, I've tried both and I don't have a preference. It's like, okay, I like both. So yeah, go for it. But like this is the kind of thing that helps you run Dart pretty much everywhere, right? And this is something that they don't advertise in the Dart website. Like the other three pillars, they were kind of like advertising the website. This is my own kind of like take on Flutter and Dart as well, right? It's like, actually it's super easy. Like I would say that I actually have never spent time learning about Flutter or about Dart in this case. And why is it, right? It's because they have a lot of things that are very, very familiar to all of us as developers. We're gonna have support for final versus var. We're gonna have optional name parameters. Like it's very easy to work with collections actually. There's extension methods as well that were introduced recently, and now if coming from Kotlin, one of the things that I miss is like nullability support, and they're actually introducing that as well. So in this case, let's take a look to the final versus var, right? So in this case, we have like a collection of variables, and the way they are defined by using var or dynamic or its type, it means that you can reassign a value to that variable at any point in time, right? But like as we know, like we like immutable things. Once we assign something, it's very, we don't change it, because then we have the question of like, oh, who changed this and all the stuff. So in that case, we can use just final, right? So as you can see, we're not specifying in any of these what's the type of our variables. So there's type inference in the system as well. So in this case, we know that, hey, full name is going to be a string because I'm assigning it to a value of type string, right? With optional and name parameters, we have something like this. We have a few examples of APIs in here. The first one is like this API authenticate. We have two strings in our method signature. So if we name those parameters, it's going to be easier to read, right? So in this case, we can use like the name, username, and the same password, so we don't mix those two. But we can also define like required name parameters, right? We just use annotations. This is coming from the Java world, having annotations. And we can say like, hey, my message variable or my message input to this method is actually going to be required. If you don't pass it, it won't compile, right? But the other one is optional, so we can pass it or not. And finally, we can have actually like default values if we want it. So in this case, dark mode is going to be assigned to false, but if we change it, could be true. Working with collections is very easy as well. As you can see, you define your list or your array, but also you can use the spread operator, those three dots, to interpolate lists in there, and the result list is going to be of the length of the entire combination of those two. Same thing with collections. So this is very handy, like, right, if you have like feature flags and things like that, like it's very simple to just drop an if inside your collection elements, and you can get that third or tab depending on whether the flag is enabled or not, right? And same thing with collections for. So in case you wanted to iterate inside a collection, you could do that as well. And we have an example there. If you haven't watched Hamilton and you ever have the chance, please do it. It's amazing. Off topic, totally. Finally, we have extension methods as well. This is very nice because if you're coming from Kotlin, you sometimes want to extend the API of a class that you don't own. So you can do this as well by just adding that extension in whatever you want to name that extension class. And then you can use it as a normal method. And then nullability, right? Like one of the things that we didn't have in Dart yet is that everything could be nullable. It was kind of like, okay, this is a pain. But now they're changing the entire framework, the entire system to support nullability, right? And it's going to be an API that everyone knows because they use question marks. And if you're coming from Kotlin, from the Android world, or even from Swift, it's like, okay, great, I understand this code. You don't have to process those changes in your mind, right? And then if you want to retrieve the value from something that could be nullable, just use the question mark, and that's it. So let's recap a little bit of all the things that we've seen, right? Dart is easy. I hope that everyone who has seen the code snippets here was able to understand what was going on. So again, congratulations, put in your resume, believe me. It's multi-platform, and it has 2 compilers ahead of time and just in time to achieve both compiling to native code and to get hot reload. It's a language that it's optimized for UI environments. It has an isolate concurrency method, pattern with event loop-based processing, and it has a modern feature set. It powers a lot of frameworks, Flutter, Aqueduct, Angular, Dart, Angel, and it's used by many, many, many companies. If you go to Flutter.dev showcase, you're gonna see in there like a lot of projects and all the stuff. So pretty much that gives you an idea of who's using what. And again, like if you like this talk, I work for Very Good Ventures. This is my first week actually as part of Very Good Ventures, and I'm spending it in Spain. But I used to work at BMW. I was leading the connected projects in Android for BMW and Mini, and we did a round of just pure native development, and then lately, like in the last 2 years, we started using Flutter. My Twitter handle is Jorge Coca Ramos, so please follow me. If you want to follow up or like engage in more conversation, in my website jorgecoca.dev, there's a option where you can like arrange a calendar meeting. It could be online, or if you happen to be in Chicago, I'd gladly have a coffee with whoever. Like actually, a lot of people in Chicago, they do that. But just say hi, because I'm here, and it's a pleasure for me to be here in Madrid. Like you cannot imagine how feel it goods. And pretty much that's it. So thank you so much.